All right, so the second type of logarithmic equation that we need to solve is type 2. So type 2 is when you have a log equal to a number. So if you look at all of the questions that you have here, you have some type of log on the left-hand side equal to some number on the right. So for this section, we're going to go through a few steps. The first step is to condense. So we saw that on the last page. Condensing means you're probably going to need to use one of the rules or a combination of the rules that you have on this page. These are the properties we saw for product property, quotient property, and power property. So we might need to use these. The next item is to actually isolate your logarithm. So the only thing you should have is literally a log equal to a number. Last couple steps are pretty simple. You're going to need to rewrite your equation in exponential form, and then afterwards you're going to solve and check for extraneous solutions. We talked about this last class. The reason why we are actually checking to see if we have any extraneous solutions is because of the domain for logarithms. Anytime you have a logarithmic function, the domain is restricted for some area. Unlike exponential functions, which are going from negative infinity to positive, logarithms have a restricted domain. So for instance, for this graph, it goes from 0 to infinity. For this graph here, it goes from 1 to infinity. So what we're trying to do when we solve our equations is we're trying to see where is your x value, and is it in the restriction, or is it actually on your curve? Okay, so let's actually solve this. So I'm going to start with question number 8. So there's methods to my madness. I'm only going to do a couple because I think you'll get it after a couple. The first step is to condense. So, Brooks, do I need to use any of the properties from this page to simplify question 8? It's okay. Do we need to use any of these properties? So, we have it minus 7 at the end. Say it again. Not really, no, we don't. Because what I'm missing here, I see the subtraction sign, I think you see it too, but we don't have a log next to it. If it would have had a log that's subtracting that 7, then yes, you could use the quotient rule or quotient property. But since I don't have that 7, or that log with it, we're going to have to do something different instead. So in order to isolate your log completely, we're going to have to move this 7. How are we going to move the 7, guys? Add it. So just add 7 to each side. So we'll have log base 3 of 4x plus 8, and we're going to make this equal to 4. All right, so from here, the next step, once we have it written in our log equal to a number, is to actually rewrite this in exponential form. In case you forgot, exponential form looks just like this. So we said on the first day, going from a logarithm into exponential is just pretty much going in a circle. So we're going to start with our base. Let me start here. We're going to start with our base, go to our exponent, which is behind our equal sign, and we're going to set it equal to whatever's next to your log. So we're going to make this 3 raised to the 4th power, and we're going to set it equal to 4x plus 8. What's 3 to the 4th power? I know it's 3 times 3 4 times, but what number? So remember, you're doing not 3 times 4, but you're doing 3 times 3, which is 80, or 9, 9 times 3, which is 27, and then 27 times 3, which is 81. From here, guys, this is just Algebra 1. You're just solving. So in order to solve, we're just going to subtract 8 on each side. So 81 minus 8 is going to give me 73. And then I'll divide both sides by 4. So x is going to equal 73 over 4. That should be my x value. Jazar, am I done with this question? Let's look back at the steps. What does it say to do next? Okay, so we've already solved, which is a 73 over 4. Let's go ahead and check this to see if it's going to work. When you're checking it, guys, use the original equation that's written on your paper. So we're going to use log base 3 of 4 times 73 over 4 plus 8 minus 7 equals negative 3. I know it looks disgusting, but this is what we're going to need to check. Jazar, if I was going to simplify this, I can multiply 4 times 73 over 4. What's going to happen to the 4's? So we're left with log base 3 of 73 plus 8, and we're minus 7, and we're setting it equal to negative 3. Guys, notice I am not solving, I am checking. Solving would mean I would move the 7 over and then rewrite it in exponential form. That's not what I'm doing. I'm having you simplify, not solve. We're just checking. In the parentheses, we're going to add, Shazara, what's 73 plus 8? 81. And then from here, remember I said you're not going to move the 7, you're going to simplify. So let's use our calculator to try to simplify this. What formula do I need to use to simplify log base 3 of 81? Change of base. So let's rewrite this in the change of base formula. What that does is it creates a common base of 10, so that way you can actually plug it into your scientific calculator. So in our calculator, I'm going to plug it in, and then I'm just going to subtract 7. So I'm going to have 81 log, so common log of 81, and we're going to divide it by common log of 3. So 3, common log, enter. Oh, nice. Simplifies to 4. So this is 4 minus 7 equals negative 3. Is 4 minus 7 negative 3? Yes, negative 3 equals negative 3. That's what I want to see. What that tells me is that 73 over 4 is in fact your solution. That would be your answer. Questions or concerns? All right, try question 10. I'm about to start it off with you, but I want you to try question 10 first. Start it off. Enya, how would I start off question 10? The first step said to condense and isolate your logarithm. What can I do first? It says to condense. Is there any properties I can use here that represent condensing? We'll go through the list. Okay, so product rule. You can't use the product rule, right? Correct. There's nothing being added for question 10, so we're good. Quotient rule, though, you said we could use. Why? You're subtracting 2 logs. Perfect. So we can use the quotient rule for sure. Is there anything else? Can we use the power rule or power property? Do you see something that's being multiplied? Yes, we can use that multiplication, that 2 times your log, common log of x. We can use that. So let's go ahead and do it. Whenever we were simplifying these on our expanding and condensing page, I told you to move your exponents first. So I would make this the common log of x squared minus common log of 4 and make it equal to 2. Once you condense by moving that exponent, now I would write it as a quotient. So common log of x squared over 4. And we're going to set that equal to 2. And it says to isolate, so I've already had my log isolated. It now says to write it in exponential form. What's the base here? 10. So we're going to go ahead and write this in its exponential form. So that circle that we made on the last question, we're going to do the same thing here. So we're going to make this 10 squared, which equals x squared over 4. And what's 10 squared? 100 equal to x squared over 4. All of this from here, guys, is just algebra 1. That's all this is. So I'm going to multiply both sides by 4. If I could actually write a 4 correctly today. I'm going to multiply both sides by 4. So this will be 400 equals x squared. And then, of course, the opposite of squaring is to square root both sides. What's the square root of 400? You don't need a calculator. 200 or 20? 20. Just 20? Plus or minus 20. Positive, negative 20. That's your x. So guys, I want you to consider here there's 2 answers. X equals positive 20 and x equals negative 20. Those are technically your 2 answers. I want to check both of them. So over here to the side, we're going to go ahead and check. So when we're checking this, I'm going to make this 2 times log, common log of, we'll use the first one, which is 20, minus common log of 4 equals 2. When you're checking these, guys, I don't want you guys to make a mistake. That's the biggest thing. So whenever you're checking questions like this, do not try to start moving things and doing your properties to simplify. What we're going to do is we're just going to start with the left and we're just going to simplify it. So I have 2 times the common log of 20. Okay, good. The base here is already 10, so I can just use my calculator to compute what is the common log of 20. So in your calculator, we're going to take 20 and hit the log button. I'm going to take this decimal, 1.301, and I'm going to multiply it by 2. This is us checking. So multiply it by 2. we have this decimal, 2.60205. And I can keep writing it, but I won't. I am confirming, does the left equal the right? Once you have this decimal, we're going to subtract it from the common log of 4. So I'm just going to subtract it from 4, common log, enter. Perfect. 2 is equal to 2. Positive 20 is a solution. Give me a nod or shake. Do you see what I'm doing? I'm not moving the exponents. I'm not changing anything. Some teachers say, oh, well, you can move the exponent here. You can divide it afterwards. I would suggest just checking it based on what's written out in its kind of form that you see here. Main thing I'm checking for sure, like we did last class, I'm trying to see if there's any negatives. We already talked about this last class. I'm highlighting 20 as my answer really quick. But we talked about this last class. Anytime you have a negative for your log, you have to stop. You cannot compute something that has a negative. So for the second question, or second part, we're going to check negative 20. Yeah, remember that conversation we just had about negative logs? I know some students will say, oh, well, Ms. Tapia, you could technically move that and make it squared. This is why I don't have you guys do that. Because if you immediately plug into your calculator negative 20 and take the log, it's going to give you an error. And I don't want you to miss that answer on your test or quiz. So once you see this negative 20 for your log, you're going to stop. Do not do anything else. I'm going to put a big X, and I'm going to cross out negative 20. This is extraneous. You cannot use negative 20 as your solution. Give me a nod or shake. Does that make sense? Perfect.